Hi, welcome students to Module 4, Lesson 8. This is the concept development portion of the lesson. And today's learning objective is I can relate a fraction of a set to the repeated addition interpretation of fraction multiplication. So we're going to really focus on the repeated addition interpretation, and I'm going to show you what that looks like. Okay, so in problem 1, we're looking at 2/3 times 6, or sometimes we refer to the multiplication sign as of. So we're trying to find 2/3 of 6. Now you remember back in 2nd or 3rd grade when you were learning to multiply an equation such as 2 times 4, what 2 times 4 meant was 2 4 times. Oh, that should be an addition sign. 2 4 times, or 4 2 times, right? 4 plus 4. And both ways that would give you your answer of 8. All right, so that's essentially what we are going to be doing in this section of the multiplication process. We're going to, instead of just doing 6 or repeating 2 4 times, we're going to be repeating 2/3 6 times. So we're essentially going to say 2/3 plus 2/3 plus 2/3. How many times are we going to do this? You're right, 6 times. 2/3. 1, 2, 3, 4, 5, 6. And because we just finished our adding fraction unit, we know that 2 plus 2 plus 2 plus 2 plus 2 plus 2 is a total of 12, and our denominator stays the same, which equals 12/3. Now, if we wanted to simplify this further, we also learned that this fraction sign is also a division sign. So what we're really saying is, what is 12 divided by 3? And we know that that is 4. So the answer to that is 4. Well, instead of writing 2/3 plus 2/3 plus 2/3 and writing this fraction and repeating this so many times, as we know, repeated addition is multiplication. So we're going to actually just simplify this process. So when we're trying to figure out what 2/3 times 6 is, what we can do is we can just, instead of saying 2, 4, 6, 8, and skip count, we can just say, well, 2 6 times over the denominator of 3. And then we can do that math. 6 times 2 is 12. We get the same result as we did here. And we remember that to simplify even further, to turn to a whole number, we can do 12 divided by 3, which gives us 4. Now to take this even a step further, let me change the thickness of that. Let's take our fraction of 2/3 times 6. And let's not do the repeated addition way, but let's do the 2 times 6 over 3 way. Now, in order to simplify even further before we get to this step right here, we can do something where it's called cross-canceling. So basically, you can look to see if your numerator and denominator share a factor. For example, I know that 6 and 3 share a common factor. I know that if I can divide 3 by 3, and it goes in evenly, and I can divide 6 by 3, it also goes in evenly, and that would change my my numerator to 2 times 2, because 6 divided by 3 is 2, over 3 divided by 3, which is 1. And then I wouldn't have to do this step right here where I'm simplifying. I would just know that it's 1, or do the dividing. I would just know that 2 times 2 is 4 over 1, and 4 over 1 is a total of 4. Now let's consider the same fraction through a bar or a tape diagram perspective. So when we're trying to find 2/3 of 6, think of having a tape diagram, and the total amount equaling 6, we're dividing it into an equal amount of parts. 3 is the denominator, And we're going to be looking for what 2/3 is of 6. So I know that 3 units equals 6. So the 1 unit would be equal to 6 divided by 3, which is 2. 2, 2, and 2. And as we can see, that 2 of these thirds is equal to 4. Just like we were saying when we were doing the math. All right, our next problem is 3/5 times 10. So it's very similar to what we've been doing. Essentially what we're saying is 3/5 10 times, or 10 copies of 3/5. Now writing 3/5 plus 3/5 plus 3/5 isn't exactly how I want to spend my day right now. So instead I can think of it in a different way. So I already showed you one way you can think of it, but what I want you to also think about it is in unit terms. So for example, I have 10 times 3/5. So when I'm looking at this right here, remember what we just talked about before is having 3 times 10 over 5, because we know that we're going to say 3/5 plus 3/5 plus 3/5 10 times. So we know that that's going to be 30/5, just as if you were to say 10 3 times, but let's call the 3, let's call them fifths. You would say that you have 10 times 3 equals 30, and you would call those 30 by its unit name of 30/5. Okay, and how we would write that as a fraction is 30/5, just as when we were to do it in the way that we just previously looked at. So looking at our 30/5, we know that we can divide 30 divided by 5, and we would get our total, or our whole number version of that, which would be 6. Okay, so let's look at number 3. Number 3 asks us what is 7/6 of 24, or times 24. So what you'll notice about this fraction right here, most likely, is that it's greater than 6/6. And we know that 6/6 is equal to 1 whole. So we know that 7/6 is going to be a little bit more than 1 whole. So if we were just to estimate the answer to this right here, we would know that the answer would probably be something a little bit greater than 24, because we're multiplying it by something greater than 1 times 24, but just a fraction greater. So let's go ahead and start solving like we regularly would. So we would write, let's see here, 7, 24 times, 24 7 times over the denominator of 6. And just looking at doing this math right now of 7 times 24, my brain is kind of screaming, no, don't do it. So I'm going to look for a shortcut. I'm wondering if I can use the cross-canceling method that I was talking about earlier. And is there a factor that is shared by the numerator and the denominator here? I think 6 and 24 have a shared factor, and I think that factor is it 3? 3 goes into, divided by 3. 3 goes into 24 8 times, and 3 goes into 6 2 times. You know what? I'm noticing that, let me do that backwards. I'm noticing that 8 and 2 still have a common, they still have a shared factor. I can divide 2 by 2 and get it even closer down to 1, and I can divide 8 by 2 and I can get that to 4. Okay, so that meant there was a bigger there was a bigger shared factor than 3 that went into both of these. But I can continue reducing it down until I get to where I want it. So my new fraction setup I'm going to write is 7 times 4 over 1. That would give me 28 over 1, which equals 28. Okay, this is the next problem in number 3. It's 7/6 times 27. Now, how is this different than the last problem we just did? You might notice that the 27, the whole number has gotten a little bit bigger. It was 24, but you also might notice that 7/6 has stayed the same, so the fraction part has stayed the same. So how we're going to go about setting our problem up is like we have been doing. Instead of doing 7/6 27 times 7/6 plus 7/6 plus 7/6 plus 7/6, that's going to be too much. So what we're just going to do is we're going to do 7 times 27 over 6. Now, I'm looking at this 7 times 27, and I'm getting a little worried because I can't do mental math with numbers that big. So I'm going to look to see if there's opportunity to cross cancel. Is there a number that I can divide 6 by and 27 by that it will go in equally? Well, right off top, I'm thinking 3. Now, if there's a bigger number, just like in the last example, we can keep reducing this down. So our new fraction is going to be 7 times 27 divided by 3 is 9 over 6 divided by 3 is 2. So 7, let me write this down. 9 divided by 2 equals 9 times 7 is 63 halves. Now I know that I cannot reduce this down any further because 2, if I'm dividing something by 2, then the last number in this digit sequence would have to be a 2, or it would have to be an even number. So I'm just going to do my division. 2 goes into, and maybe if you set it up like this, this is okay too. 2 goes into 6, 2, 4, 6, 3 times. 2 goes into 3, 1 time. You're going to have 1 remainder, and the divisor is the denominator. So the answer is 31 wholes and 1/2. All right, so our last problem, which is problem 4, asks us to find, it says 2/3 hour is equal to how many minutes? So we're going to look at this both ways. We're going to look at it with the tape diagram and without it. Let's start without it. So 2/3 of an hour, they're trying to figure out how many minutes we're looking for. So what we're looking at for is 2/3 of 60 minutes. Now remember, of means to time. So what is 2/3 times? We're going to call it 60 because that's the answer. That's the units that they want answered. So what is 2/3 of 60? Now I could write 2/3 plus 2/3 plus 2/3 60 times, but again, that's not how I want to spend my time. So instead, what we can do is we can do 2 times 60 over the denominator of 3. I'm going to look for any shortcuts for cross-canceling opportunities, and I actually think that 3 goes into both 3 and the 60 in the numerator. And when I do that, I'm going to get an answer of 2 times 20 over 3 divided by 3 is 1. Now when I solve that, I get a total of 40 over 1, which equals 40. Okay, and lastly, I have about 20 minutes, but the tape model way shows that the total represents the 60 minutes. If we're looking for 2/3 of the hour in minute form, then basically we know that 3 units equals 60 minutes, 1 unit equals 60 divided by 3, which gives us 20.